Hello everyone, welcome to today's webinar, Industrial Design with Power Surfacing for SOLIDWORKS. Power Surfacing 5.1 at this point for SOLIDWORKS is a powerful industrial design tool for creating complex organic geometry inside of SOLIDWORKS. It is fully integrated with SOLIDWORKS and it creates native SOLIDWORKS geometry that resides within SOLIDWORKS and in the SOLIDWORKS feature tree. Power surfacing geometry can be shelled, filleted, booleaned, analyzed, and so on, just like all other SOLIDWORKS geometry. Today's webinar presenter, Sue Blackman, is a 3D artist, author, and educator. She is author for Apress, Lynda.com, and AMC Siggraph. Specializing in combining game technology with CAD data, she has been involved with the development of 3D applications, training material, and workflow analysis for well over a decade. Now, let me tell you a little bit about Novedge and what we do. Novedge is one of the largest online stores for design software. We have a huge assortment of software solutions that cater to virtually every designer's needs. So come visit Novedge.com and see for yourselves. And for more daily software news and promotions, follow us on Facebook, Google+, Twitter, Instagram, you name it. And I want to remind everybody that I will be recording this session and you can find it later on today on the Novedge Vimeo and YouTube channel. And now let me introduce David Gill, who's also from the Integrity Work team, and he will do a small intro and then right before Sue gets on stage. Take it away, Dave.
Thank you for joining us. I'm David Gill, president of Integrity Ware and NPower Software. We're a technology company that specializes in geometric modeling, and we license our technology to many companies, but NPower Software is our end user products division. So I'm going to give you a very brief overview of power surfacing for SOLIDWORKS. It's our award-winning industrial design product for SOLIDWORKS. The last two times at SOLIDWORKS World, where they've chosen the best software product, power surfacing has been that selection. We also have a standalone product called Cyborg 3D that has the same functionality. But power surfacing is, as Paul McCrory describes, surfacing made easy for SOLIDWORKS. It creates native SOLIDWORKS geometry, native solids and surfaces. We have several patents that this product is based on, but the key thing is it works right inside of SOLIDWORKS and it's integrated so that it works just like all SOLIDWORKS tools do, with all of the functionality that's available to SOLIDWORKS. Here's a list of some of our typical customer industries. We have a wide range of customers, and I'm sure that some are missing from this list, but this gives you a kind of an idea. There's a number of kind of minor industries within each of these, but we have many customers across a wide range of applications and disciplines. Here's some customer images that I put together quickly just to show you an idea of some of the things that people have done with our software. There's a lot of automotive stuff. This is an electric car, fully electric car that was designed by Andres Van Overbeek, who does automotive design, furniture, various different types. This is a guy that does design with our software, modeling cars and such. We have a lot of medical and like prosthetic designers. This guy does interesting balloon artwork. His company is called Designs in Air, and his stuff is shown all around the world, various different places. So why power surfacing? The advantage of power surfacing is that it's fully integrated so that, for instance, you can constrain to SOLIDWORKS geometry. You can apply all SOLIDWORKS features directly inside of SOLIDWORKS to our power surfacing bodies, and they behave just like standard SolidWorks geometries. So we feel, and people that use the product feel, that it is the best industrial design and surfacing tool for SolidWorks. So with that brief introduction, I'd like to turn the time over to Sue Blackman, who will be doing the product demonstration.
Okay, so here we go. I don't know how many of you are familiar with subdivision surfacing type modeling, but I'll just give you a really quick peek at a very simple sub-D, and then I'll go into showing some of the things we can do with them. So from files, or actually I think I'll go straight into tools here. So tools, power surfacing, creation tools, and I'll create a box. And what we call a box, well, you can see part of it looks like a box, but the rest of it doesn't. So what you're seeing here is you're seeing the sub-D, and that's what it's going to look like when it gets converted. You're seeing a sub-D plus cage, and the cage represents the control mesh. And this is where all the data is kept on this guy. And if you were to, I'll put the cage back on here so you can see, if you were to increase segments, you can see the more segments, the closer the sub-D gets to the shape of the control mesh. But we'll just keep it simple for right now. So I'll go ahead and accept this guy. And I want to show you some of the things you can do with it, just a few things. So I'll switch back over to my sub-D display. And you can select part of this. And I'm going to go ahead and give it a hard edge. So this, you know, we've got lots of tools to work with. But the main thing I want to show you with this is if we convert it, so it becomes a regular SolidWorks object, I can go ahead and do things like put a fillet on it. And then I might say, well, you know, I'm female, I have the right to change my mind. So I'm going to go back into it and edit it. So I'll go back into my power feature and I'll drag this guy out a bit. And maybe I'll drag this guy down or something and convert again. And you can see that it updates with the fillet we put on it over in the feature tree. And there's some other stuff you can do with it. A lot of tools. You can insert loops and do all sorts of things with these. You can extrude, and it's all kinds of fun stuff. If I hold my A key, we've got shortcut keys and a whole bunch of stuff. But this isn't really about how to use it and, you know, how to use the modeling tools. Today, what we want to show you is what it looks like when we have more finished things. So I'm going to close this for a minute. And one of the things we're going to be sort of highlighting.
Sue, we lost your audio for a second. Do you mind checking your microphone? Sue, if you can. Oh. Okay, you're back.
Oh, okay. You know what? There's a button that hits mute on the actual headphones. I must have hit it. So where did I go? Where did I go dark?
A few seconds back.
Oh, okay.
It's only been a few seconds, so nothing significant. So.
Okay, good. All right. So before we jump into the more interesting stuff, there is kind of a, as I started to say, and I probably didn't get through, was we're going to show a lot of the constraint stuff, and one of the things I want to show is what type of constraints or what type of tangency our constraints can use. And I have this little sample here. And what we've got is we've got 3 different types of constraints. Now we offer more than that, but these are sort of the main ones. And this is with our sub-Ds constrained to a SolidWorks cylinder here. And on the left we have no tangency. In the middle we've got our default tangent to surface. And on the right we've got our G2 or curvature continuous. And in case some of you guys are not Zebra users, we'll go over to the evaluate and turn on zebra stripes, and you can see really what's happening. So no tangency is just sort of sitting there, and curvature, or actually tangent to surface, you can see the stripes connect, but not smoothly. And in the curvature continuous, the G2, you can see that they follow the curves all the way up. So we've got these different options, and this is on constrained to a surface, but they also go through to constrained edges and other things. So let's close this guy. And the next thing I want to show here is the cordless drill. Yes. So this is a file that uses 3 main power surfacing features. One is this top body part, another is the handle, and the third is this lower section that covers, say, a battery. And the rest of this is all SOLIDWORKS. So let's see what we got here. What we can do is say, I might decide, well, you know, I want to change the draft on this. And this is kind of a nice sleek shape here, but I can ruin it. So I'm going to go into my extruded circle here. And I'm going to change that draft angle to about 12 degrees. And that doesn't look like very much, but you'll see a bulge when we get back. So it's updating the power surfacing that uses constraints all down the line because it has changed the shape.
Yeah, it's actually updating the whole feature tree and all the downstream dependencies.
Because they're some of them are very dependent on each other. Okay, so there we go. And now you can see it's kind of got this bulge here. And the next thing is this handle. And what you can see is this guy actually had to do a trim and knit to go into there. And in our latest versions of power surfacing, the trim and knit is now automatic, or it's one of your options anyway, which is really nice because it takes a lot of extra work out of using this sort of thing. So I'm going to go down into this handle, and I'll go ahead into edit mode. And you can see we've got some constraint surfaces defined, so these edges know where to go. And they're all sort of sitting there nicely, but I might decide I want to do something to this poor handle, because I usually do. And this time I'm going to show you something else we offer, and that is level of detail. So level of detail lets you work, I'm going to get in a better view here. Level of detail lets you work in a higher subdivision, and you'll see I can just sort of pull out some hand knob things here, some grips. And that was a fairly simple thing, but here's the cool part. As soon as I accept this and go back into level of 0, 1, or 0 actually, they're still there, but I can now affect my main mesh with just the little bit of geometry it already has. And it's looking a little chunky because I do need to see a few more subdivisions in the viewport, so I'm going to crank those up a little. But now watch what we can do. We can take this guy, and the stuff that was done in level of detail in a different level tries its best to retain its offset from the original. So that's a pretty nice way to be able to model. You could still have control over the smooth, larger shape, but yet you can add more detail like this. So I'm just going to, rather than let that convert, I'll go ahead and cancel it. Well, I don't know, maybe I'll try it. I'll let it convert. And that's kind of the last one. This one I'm going to show. So we've got lots of ways to connect things. We've got ways to add more detail and keep the workflow fairly fast. And there we go. It's updated. Updated all the connections. And there we are. So now you might be thinking that, well, that's a few things, but my feature trees look longer than that. Well, I can do that too. So this time, I'm going to show you another one that's used a lot of constraints and a lot of SOLIDWORKS stuff as well. And that is our drone. And this I used a photo of one at some conference or something because it was a really nice organic shape, and just to see how I could model it. You say that's yeah, more complicated than I usually do. Ooh, I seem to be missing one of my SOLIDWORKS propellers, but that's okay. So this one I'm just going to sort of do a reveal for you for most of it, and I'll start up at the top. If I can get there from here. And other than some imported stuff like the propeller, my base object I started with was just a fairly simple power surfacing sub D body. It just looks like that. It's got a couple of interesting things. It's got a weighted edge up here that kind of changes the shape a little bit, but otherwise it's pretty simple. So I'll cancel that guy. And then on top of that, I used my constraint of face to create a tail column, and you might want to see the surface breakdown here. And on top of that, I added a tail piece, but that I'm going to go ahead and just combine or Boolean in later. So let's see what else we've got on here that's interesting. And I did a bunch of SOLIDWORKS stuff, so I'll skip down here. And before I show you the arm piece, I'll show you my sketch that I was using. Let's turn that guy on. So I had a sketch that I was using, and the two things that I added here are I added the two, well, besides the regular SOLIDWORKS stuff, I added a couple of cylinders, and I probably deleted the faces on them. Yes, I did, because I want to make a solid later. And from there, I added my power feature arm. And this is a very easy shape to make. And I think I used the sketch as guidelines for it. And once I get out of that, I knit the pieces, and it is a solid at this point. So the next piece, though, is bridging between the body and the arm, and I had lots of fun with that. And it's using a constraint of face on both sides. And there again, it automatically trims and knits for us. And then I got even wilder with this one and used the same techniques to create the scoop. And this one I was challenging. It was challenging because I wanted to see how thin I could make this piece there. And you see it just dropped right in. So let's see what we got now. And power feature leg. I used a power feature for the leg. And so that was a nice shape to get with that. And I could adjust it as I went to decide how much curvature I wanted and where I wanted the curvature and stuff. And once again, a delete and knit down to the SOLIDWORKS features. Now, one of the things you won't see here is somewhere in here I hollowed out this wing, or this connector to the wing. And I hollowed it out with another piece I'd made with power surfacing I probably used thicken or something to start it so I could get a nice even piece there. And then I did a cut extrude. And this is a design feature that was in the image that I was working from. Okay, now the next thing was I made a piece to Boolean to combine subtract for my cockpit area. So that left us with something like that. The next piece I didn't, I kept as a separate piece, and I do this a lot. You might actually be working in assemblers or something if you have as much stuff as I do in here, but I kind of like to keep it together for demos. So the cockpit then, what I want to show you here is, we'll go inside here. It's a fairly simple piece. But remember that I said that we have different types of tangency? Well, one of the things I didn't tell you was that you can combine them. So if I select this loop of outside edges, it would have come in, originally would have been constrained to edge, and the constraint would have been tangent to surface. So it would have looked like that. So you can see it comes tangent off of that surface and kind of bumps up and goes smoothly back there. And I thought, well, for this I wanted a little more definition on that. So what I did was, actually I should have left that open. What I did is I set everything to no tangency, and then I picked my 4 back edges. So this guy, this guy, this guy, and that guy. And I did my override constraint where I can change the tangency. And these I said, okay, well these I want to be tangent to surface. So it looks like, oh, it looks like I forgot to do the other one again. I'll do it in a minute. So these back here will be tangent, and then the rest of them, so I've got to select them again because I thought I'd already done that. The rest of them then I will control out these because I don't want these to be no tangency, but I'll go back and override the tangency on these and say no tangency, please. And there we go. So you can combine the tangencies to get some really nice effects. So I don't need to save that one, so I'll cancel out of it. So it doesn't need to update for us. And then down at the very bottom, I think the last thing I did was I added a thicken to that piece. And we've got some other stuff going. Hide the sketch. And so it's a fairly complicated model, and it uses a lot of both SOLIDWORKS features and power surfacing features as well. Okay, so I'm zipping along really fast, so hope you guys have lots of questions. So the next thing I want to show you is a new feature we have. And when I say new, I mean it is new as of Monday. And I got to play with it yesterday a little bit. So we'll show you what we've got so far. And we may refine it a little bit. But I think those of you who do injection molds and stuff are going to be really pleased to see this thing. So I'm going to start out with a very simple model, torus. And I've already created a plane to tell me my direction of pull here. And I'll go ahead and go into this ridiculously simple piece. And you know, if you've got curvature like this, you know it's going to do well with a parting line. So I'll go ahead and I'll add a parting line really quickly. And if I tell it to preserve shape, depending on your geometry, it will do its best to do so. And if I were to run my draft angle on that, as soon as I take a cat hair out of my mouse, there, that's better. First, what I need to do to see my draft angle is I want to select my plane, and then I turn on curvature. Oops, not curvature, draft angle. I hit the wrong one. And you can see the familiar red and green and yellow, unless you turn them to different colors. And it's set to 3 degrees right now. If I hover, you can see what the draft angle is. And you know, this is curvature, so it's always going to be pretty good. So I'll go ahead and let's undo that. Do something a little more challenging. And this time when I put my parting line in, I'm going to let it stay like this so it's fairly flat here, because this is where it starts getting better. So now I've got this thing, and I could again choose my plane and turn on my draft angle. And if I hover now, I've got, ooh, I've got a minus 82 and I've got a positive plus 82. And usually what you would do, or actually usually you would set your edge to hard edge. And it's not going to make any difference on this one because it's fairly flat here. But if I now scale this selected edge out, you can see that my area gets smaller and smaller. And right about there, if I hover, I now got 3.87, so it's still maybe a teeny bit big. You can increase the viewport subdivisions level sometimes, and that'll help you out. Also, the other thing you would want to do with this is you want to check your numbers over in SOLIDWORKS, because they're similar, but you always want to do a final check after it's been converted. So if I was to take this over now to SOLIDWORKS, convert it, and then go into my evaluate and do my draft analysis. And I'll choose the same plane there, like so. And we can see that that's pretty accurately pretty good. So you might be saying, well, yeah, that was really kind of a simple one too. So what we'll do is we'll choose one. It's still going to be fairly simple because I don't want to spend a lot of time on it. But what I can do is I'll show you one that's a little more challenging. So let's close this guy. And now we are going to open up remote controller draft. Okay, so this is some kind of funky looking remote control of some sort. And the original design actually had it, so it was pretty good draft wise, but I made it flatter around the sides so we can mess with it. And so once again, I've already defined my plane down there. And let's go into edit this guy. And let's see what we got. So I'll select my plane, and I want to see where I am draft-wise. And I can see, well, you know, it kind of wants to draft up there, and probably if I selected this whole loop around here, that might not be bad, but you know, design-wise, I don't want it that close to the top of this thing. So I'll go ahead and double-click this guy, select a ring of edges, and I will insert an edge and accept that, make it a hard edge. And we can also do partial creases too. A hard edge is 100% crease on that, which is what you want for your parting line. And then you're still thinking, that looks like it could still be a lot of work. Well, just because it could be a lot of work, I've gone ahead and I've mirrored this. So if I grab something here and pull on it, you can see it happens on the other side. So we've got mirror capabilities. And we've also got a pretty much unlimited undo stack, which is nice. So I kind of need to see what to do here. So I'm going to, I'll select this whole loop. I've double clicked on it near the end of an edge, and that's going to give me an edge loop. And so I think what I want to do now is I'm going to try scaling it a little bit. You see the underside of this thing dips pretty good, so it's not in bad shape. And so I've helped some of it already. This time I'll maybe pull some of these in so the end pieces aren't too bad. And I'll select some. And I'll pull these guys out a bit. Okay, so already that's a pretty good choice. And I've got some funny stuff going up here. So but one other thing that you're seeing, which you may not be registering, is that I'm watching my draft angle and able to edit at the same time. And so that makes things a lot nicer. So now I can go over here and I can say, well, I can pull this guy out. And I could be looking at the numbers, but I'm not going to bore you with that. I'll just get it kind of close, like so. And I think we'll probably at some point be able to let you dial in how fine of control you want over the transforms on these things. And I look at this one, that's still pretty high on that. So maybe I'll select this edge. I'll select that edge and pull them out just a little. maybe too much. Now the problem is if I keep pulling, it's all going to show green, but I don't know how much angle I've got unless I go out and check it. And so we've got kind of another trick you can use here, which is pretty cool. And that is, if you get a little, I'm going to get a little closer on this one too. Oops, too much. And this one up here, I think I'll pull on this guy. Oh, I'm going to push that one back. Maybe, okay. I'll forget it for now. But right now we're looking with our draft angle set to about 3 degrees. And if we do this, this is a trick. I'm going to set it to 6 degrees now. And I'm going to use multiple colors. And what that's going to let me do is, that shows me exactly where my 3 degree is color-wise. So say if I pull this guy out, actually, I think I just want this vertex. So I'll switch over to vertex, and I'll pull him out, maybe a little more, maybe pull this whole guy. And so as soon as I get down to where I've hit yellow, then I'm probably pretty close to that 3 degrees I need. Let's try this one over here. And maybe the front. So what we've got here is, if you see about 50%, then of our 6 degrees here, that's 3 and that's 3. And I'm just saying about right now. So I kind of know that as soon as I get down there, it should be pretty good. And then I can go along. I don't think I have to worry about the underside because it had plenty of draft to it. But now I can go through here and kind of fine tune it. And that was obviously the wrong direction. There we go. And I won't bore you with the fine tuning. At least I don't think I will. Okay, there we go. And if I go back to 3, we've got something like that. Now there's a little spot there. If I hover it, it's 3. Yeah. Well, we'll try it because, as I said, I think we're a little. I think by the time you convert it, you might get a teeny bit of shrinkage. So I'm going to try it and see. So I'll go ahead and convert, and we'll go over and evaluate, and do our draft analysis. Pick our same plane. And yeah, see, so that one went away. So it was close enough that it wasn't a problem. So that's this is like hot off the press, the dynamic draft analysis while you're in edit mode. And we think that you guys doing the injection mold stuff will be really pleased with that. Okay, so still doing pretty good time-wise. So I've got some other ones I want to show you. And the next one is, if we close this out, don't save. The next one is combining this constraint stuff with our Retopo type of constraint. So it's two different methods. The power surfacing RE is I don't want to say it's a separate, but it's sort of an add-on to power surfacing. So it's a separate product, sort of. And the nice thing is you can use them together. So I've got this sample here, as soon as I remember what it's called. And that should be test connectors base. So this is a scenario that, I don't know, I think they did pellet guns or something, a company of pellet guns. And what they said was, well, we've got all the SolidWorks stuff for like the barrel and the stock and stuff. These are not high-end ones. These are the stuff you give your kids for Christmas. So anyway, so this stuff was all made in SolidWorks. But they said, you know, it's really important that we model this out of clay and scan it in, and then we need to be able to connect them up. So that's what we're going to do with this one. So power surfacing, import reference mesh. And here's our connector reference object. We read in OBJs and STLs for reference meshes for our RE product. And it looks something like this. And what we're seeing here is we're seeing some pushback. This happens that we use the graphics card to do, but we can adjust it so it won't be so spooky looking. So we got this thing. It's pretty organic. And another thing I can show you here is that rather than modeling that centerpiece, I've already got one, which means if you go to Power Surfacing, you're already in an edit mode, which we are here. You can import the sub-D mesh, and you can use something that's ready-made. And for those of you who do variations on the same sort of object, you can have a library of useful things. I know especially the medical guys, you know, where they're doing prosthetics and things like that, they might have 3 different sizes of something that'll go around a foot. And then they scan the actual person's foot, and then they can start with something that's fairly close and not have to reinvent the wheel every time they want to make a new part. So this guy will go ahead and constrain this to the Retopo mesh. And right now we're seeing it in control mesh, so it looks very chunky. And as soon as we switch over to sub-D, we can say, oh, hey, wait a minute, it shrunk in. Well, sub-D shrink because that's how they maintain that really nice curvature. So we can also tell it to shrink wrap. We're just going to push that back out onto that surface. It's a little chunky because when we import an OBJ, where display levels are set to 1 just in case someone pulled something really large in. And if I tip it over, I can see it isn't really as close as I need it to be, so I'll give it 1 more iteration on the shrink wrap, and that did a pretty good job. So I'll say, okay, I like that. Now let's see about connecting these edges to our SOLIDWORKS analytics. And to do that, we do the same thing. So we'll go over to our Power Surfacing, and you haven't seen me use this yet, but this is how we get those surfaces for constraining to. So we do import reference, and those of you who have used this before, we've made changes in the 5.0 series, and that is when you pick it to add the constraint surfaces, you won't see the yellow mesh until after you accept. So be aware that that is a difference. It's not broken, it's just working slightly differently. So I'll accept this. Now we see our constraints. And now I'll go ahead and I'll select both of my open edges here. And I'm going to constrain them to edge. We saw a few things change. And whenever you're tweaking things that have also got an RE Retopo constraint on them, you want to go back over to the Power Surfacing RE and just say update the constraint. You can see it just did a tiny little twitch there. But now we can go ahead and convert, and we've got our accurate connections, I think. Come on, wake up. Wait a minute, did I turn something off? I'm not sure. Oh, I've done something wrong this time. Well, anyway, at this point, I've got a graphics issue here that I need to look into. But at this point, you could go ahead and select them and do a knit, and everything would be nice. So it lets you convert, it lets you combine RE and regular Power Surfacing constraints together. Okay, let's see here. Let's open the next one. How are we doing on time? 40. Okay, so I got a couple that you can just kind of take a quick peek at. One is applique. So this is another thing you can use constraints or also partly some of the RE tools as well if you have both. So let's open up applique sample, and you can kind of see how I laid this out and how I did it. So I've let my I've done an offset on on the top of a bottle, and used it to apply an image template, and then I went ahead and modeled my sub-Ds. And I saved these guys to libraries so I could pull them back in and I didn't have to redo them each time. And in the end, what we end up with is decal final. Something like that. And there's a few different ways you can do this. This particular one, I actually extruded them and used combine because I wanted to be able to I didn't want to have to deal with overlaps, so I thought I'd let SOLIDWORKS did it, and it did a did a very nice job. And I've even got a little fillet on the bottom bits there. So that was something that some of our customers have been asking for a while, is how do I do an applique sort of thing. And then the last thing I'm going to show you, and then we'll take some questions, is we can also, you've seen the constraints used to bridge exterior pieces. Well, you can also use it to bridge interior and make holes. So here's a little sample I did, and sort of started out with a bicycle helmet. Well, okay, it's half a bicycle helmet, and then I made a pattern in it. And let's go ahead and unhide that. So we'll go over to Edit Feature, and you can see what I've done is I've used constraints. I've constrained my edges to the surfaces, and you can see the constraint surfaces. They're nice little grids. And I'll go ahead and hide my helmet piece now so you can see what's happening on the interior. And I've added an extra edge here, an edge loop in between, because if you're constraining, you should always have at least one loop in between two constrained surfaces. And the other thing I've done with this that is kind of nice is, rather than sit there and pick everything so I could delete it, what I did was we have a selection set manager that lets you record, or not record, but it lets you store selection sets. So I'm going to select my faces here because I don't need those because I'm making a hole, not making a bump. And I'll go ahead and delete those guys. And I should probably remove that since we don't need it anymore. And it's already constrained, so I should be able to go over to my feature creations, and there's no post-processing, or you could create a 3D sketch. And usually what we've been doing, most of these things you've seen have been using delete and knit. So we're going to use that one. You can also change the quality, and there's a few other adjustments, but that should do us on this one. So we'll let it convert. Constraints can take a while to convert because there's a lot of, they're making sure that they're stuck to the constraint surfaces. But this was kind of an interesting inside-out way of modeling. Oh, yes, and I turned this guy off, didn't I? So I should turn it back on. That guy. Okay, there we go. So there it is, using the constraint system to bridge between two surfaces. And I could have gone in and I could have changed the shape of the interior part here, but that was just a simple one. Okay, so I'm going to let Dave take over now and see if we have any questions.
Yeah,
okay, so we do have some questions. First of all, Mark asked a question about inputting dimensions. Now, you can't dimension as easily as you would probably like. You can dimension to the
control mesh.
Control mesh, the points on that, but that's not typically what you want. If you look at that helmet shape, you want to dimension to sort of the smooth surfaces. So what you can do for dimensioning is you can dimension to any SOLIDWORKS geometry like a plane or a surface or whatever, and then you dimension to that. So for instance, if you want to set up a parametric part that has a dimension between, say, two planes, you can dimension to those two planes, and then you can constrain to the plane so that as you update the dimension, the geometry will change as well. So that's how we handle that. It's not that straightforward because the shapes are kind of organic, and sub-Ds, they round off, as Susan was saying. So you have to sort of be thoughtful about how you do the dimensioning. Okay, Chris also was asking about doing models like the Lamborghini Aventador type of shape, which basically has a bunch of kind of creased edges or harder edges, and we can do those as well. If you remember the electric car model we showed at the beginning when we were showing the customer images, that's kind of a similar type of thing where it has a bunch of creased edges along with the smooth surfaces. So you can put in creased edges to get hard edges, but you can also make soft crease edges that are not fully 100%, that look sort of like a fillet too. So you can create all those different types of shapes and combine them and do all sorts of stuff with that. So you can easily create that type of car model. In fact, a lot of the car modeling is done with subdivision surface modeling these days. That's what Tesla uses, and that's what a lot of advanced car modeling does, because car manufacturers want to create what are called Class A surfaces, where they're nice, smooth, and continuous, and sub-D modeling creates Class A surfaces by default. If you want to put in an edge and break that continuity, like Susan has done there, you have to do that explicitly by selecting the edge and making it what we call a creased edge. And again, the crease can have 100%, or it can be a softer crease that looks kind of rounded.
And you can also put a crease on vertices as well, a weight.
Oh yeah, good point. Good point.
This is going to be scary.
All right, and then Chris also had a question about importing industrial design models created in 3ds Max or other sub-D modeling systems. And yes, that's one of the nice things about power surfacing is you can import models from 3ds Max, Modo, Maya, Softimage, even ZBrush. We've got a way of bringing in ZBrush models. So yes, we can import those in, and then they behave the same way. The key with 3ds Max is 3ds Max has a couple of different polygonal modeling systems. You can model things with triangles, or you can model with quads. And the things that are modeled with quads will come in easier than the ones with triangles. So typically the ones that are done like sub-D models using what's that called?
Mesh smooth.
Mesh smooth, yeah, mesh smooth. Anything that has the mesh smooth on it comes in pretty well. So,
although you usually want to tell it not to have the mesh smooth already on it when you bring it in.
Correct. Yeah, that's correct. Yeah. Bring it in with a control mesh and we'll round it because it does the same rounding basically. So those are the questions I see there. Are there any other questions? Does anyone else want to post a question?
So far, these are all the questions, but we're here another couple of minutes. So don't be shy, ask away. Oh, are there issues when going to do 2D? 2D.
To 2D?
Yes.
No, not really. It's basically the same as any other SolidWorks geometry that you mean for like a drawing, right?
I guess
that's
Let us know,
like
Mark.
SolidWorks geometry, so no, there's not any issues going to 2D.
Cool. Yes, we'll be sticking around another couple of minutes if you think of something. Oh, another question. Can we use power surfacing to export SolidWorks model to OBJ format?
Well, you'd have to use the power surfacing RE product to do that. So the answer is yes, but that's one of the things that's that it requires the power surfacing RE product, because you have to turn the SolidWorks geometry into sub-D geometry in order to do that.
Okay. And what are the most notable features you would say that this version has compared to the previous one?
Sue, you want to answer that? Because I probably missed some of them.
I would definitely say the new draft angle is a strong one, and we've had constraints before, but we haven't had constraints that do all the trimming and knitting for you when you're constraining to surfaces, and that's a massive time saver there. So that's one that we really like to talk about.
Offset strengths too is another new one.
Oh,
you
right, yeah.
On a surface that's offset from another one. So they use that a lot in sort of clothing, shoes, and helmets and things like that. What other ones too?
You probably have the feature list over there.
There's that constrained hole on a thin shell type thing. I don't know how to describe that in layman's terms. You want to try?
Well, that was like the dolphin shape on the bicycle helmet. I mean, that's not really new. That's just that we suddenly thought, oh, wait, we can do this the inside out way. So that's one. But there again, it's using that nice trim and knit, which is a massive time saver. Mm-hmm. And the RE and constraint system working together now happily is a good thing as well. That's a new one.
Well, cool. Yeah. That's a great list. David, I sent you another question from Mark.
Oh, okay. I see. Okay. No, there shouldn't be any. The question is, he's using a CAM package in SolidWorks, and he wants to know if there's any issues with 3D machining. And no, there shouldn't be. Again, it's just like any other SolidWorks surface. In fact, you tend to probably get better surfaces with power surfacing, so those should be fully machinable. And one of the advantages of power surfacing is that you get, by default, 3D printable parts too. So if you're using 3D printers, we create a watertight solid by default, so it is 3D printable without any extra cleanup. But you shouldn't have any trouble with CAM packages. It should work with that geometry. And many of our customers use CAM and analysis and all the other packages in SolidWorks along with our tools. And there haven't been any problems at all.
Wow, a great tool indeed. If you don't have to do extra work, that's what we love. All right, guys, I think, one more question. And which improvements did you add in this version? I think we did answer to that question.
I think Sue kind of covered that.
Yes, yeah. I think so. I think so too. Go back and watch the recording as early as this afternoon. I will be posting it on YouTube and Vimeo on the channel Novedge. So you can watch it over and over again. All the questions are there. Can you use sketch curves to use as surface control curves, similar to normal? Okay.
You can constrain to sketches, yes.
Yes, you can constrain to sketches actually in multiple directions too. That's another feature that's new in the 5.0 version. So
one of the things that we didn't mention, mainly because it's not something you can see, is that the files are now a lot lighter weight and the conversions are a lot faster than the earlier versions. And there's probably other under the hood things that I don't even know about, but there were a lot of changes in this version.
That's a good point. That's a good point, Sue.
Cool. Thank you so much. Okay, I think this is it. I will take the screen back. This is where you can find the recording of today's presentation on Vimeo and YouTube. Thank you all for attending. And since you like power surfacing so much, I want to show you where you can find it at novedge.com. Just type in the name in the search box and the product will come up in all its versions, upgrades. And thank you for joining us today again. You can find us on Facebook, Google+, Twitter. And again, you can watch it over again on YouTube and Vimeo. Thank you so much, Sue and David. That was an excellent demo, and you received awesome feedback throughout. It was a wonderful time to spend 1 hour on a Wednesday morning.
Well, thank you for inviting me again.
Bye-bye, everybody.
Thank you all for those who attended too.
Bye. Have a
Bye.
great day.